Yes. All right, so here we go. The calculus of logarithmic functions. The derivative of the natural log of x is equal to 1 over x. The derivative of log base b of x. What is the base of natural log? E. And what is the natural log of e? 1. So in this situation, the derivative of log base b of x is 1 over x, but then we have to multiply by the natural log of b. Had you done this in this previous example, the natural log of e is 1, so that part would just go away. Now, if you remember yesterday, I showed you two other derivatives. I said that the derivative of e to the x is equal to e to the x. If the base is not e, then the derivative of something else, so say b to the x, would be b to the x times the natural log of b. You see how these are related? Okay, so just an easy derivative. Derivative of e to the 2x. Do you remember from yesterday? What's the derivative of 2x? 2 times e to the 2x. Okay. What is the derivative of 7 to the x? 7 to the x times the natural log of 7. That's it. That's what we were in yesterday, and we tied in the chain rule, and the quotient rule, and the product rule with it. So we're going to find the first derivative two different ways, and the second derivative two different ways. So you're going to learn about the nice properties of logarithms and how we can use them to take derivatives more easily. What rule would you use here to find the derivative of natural log of 1 over x squared? Chain rule. What is the inside? 1 over x squared, which is x to the negative 2. And the outside would be the natural log of u. What is the derivative of natural log of u? 1 over u. What is the derivative of x to the negative 2? Negative 2 over x to the third. We multiply the two together and substitute the x to the negative 2 back in. We get 1 over x to the negative 2 times negative 2 over x to the third. Negative 2 times 1, negative 2. X to the negative 2 times x to the third will give me just x. Because I wrote it as x to the negative 2. So this is what I substitute in for you. The negative 2 right here. So the derivative of x to the negative 2 is negative 2 over x to the third. I multiply these two together, and negative 2 times 1 is negative 2. Can I show you an easier way to do the problem? You like easier, right? Well, I'm going to write this as natural log of x to the negative 2. Now you need to see something that we learned yesterday about logarithms. Use a law of logarithms to rewrite that. What can I do? Yep, move it to the front. So natural log of x to the negative 2 is the same thing as negative 2 natural log of x. What's the derivative of natural log of x? 1 over x. So what's the derivative of negative 2 natural log of x? Negative 2 over x. Easier, right? Okay, but you have to be able to look at it and recognize that you can do that then. Okay? So let's look at B. We'll take a very similar approach. I'm going to do it the easier way first, and we'll do it the harder way the next time. Okay? So what I'm going to do is I'm going to take this 2x, and I'm going to move it out front. So I have f of x is equal to 2x times log base 4 of e. Can you tell me about log base 4 of e? What is it? Oh, I get it. So you're looking at the derivative of it, right? Is there a variable here? No, this is just a number, right? This means 4 to what power is e? This is just some number. So don't even look at this right now. What's the derivative of 2x? 2. So what's the derivative of 2x times this other constant? Well, whatever 2 times that constant is, right? We only have one variable. It's just x. If I would rewrite this, 2x times pi, what's the derivative of 2x times pi? 2 pi, right? So the derivative of this is just 2 times log base 4 of e. Now let's do it a different way. Let's use the chain rule, okay? That is the answer. That's all it is. Let's use the chain rule, and I can see that my outside function would be log base 4 of u. What is the inside function? E to the 2x. Looking at our notes, what's the derivative of log base 4 of u? Natural log of 4, but 1 over u, natural log of 4, right? So that's what our notes say right here. Take 1 over the variable times the natural log of the base. 1 over the variable times the natural log of the base. What's the derivative of e to the 2x? Of 2e to the 2x. Now I multiply these together, correct? So I have 1 over e to the 2x times the natural log of 4 times 2e to the 2x over 1. Now what's going to happen? And I get 2 over the natural log of 4. Do our two answers look the same or do they look different? They look different, don't they? I'll show you that they, and I would accept either one on the test. But I'll show you that they are the same. I'm going to change this base. Instead of having a base of 4, I'm going to change it so it has a base of e. So what do I write if I change the base to e? Instead of log, I write natural log. So change of base formula, which we did yesterday, or 2 days ago, was natural log of this number divided by the natural log of that number. Okay? What is the natural log of e? 1. We have 2 over natural log of 4. And you can see that they are the same. Either way is fine. Let's look at C. What rule do I have to use for C? Quotient rule. What's the derivative of the bottom? E to the x times the top, natural log of x, minus, what's the derivative of the top? Over x times e to the x, which is the derivative of the bottom. Whoop, what am I doing? I'm sorry. I ate a bowl of stupid for breakfast. Let's try again. The derivative of the top, what's the derivative of natural log? 1 over x times the bottom, e to the x, minus natural log of x times what is the derivative of the bottom, e to the x. Much better. Divided by what? What is e to the x squared? E to the 2x.
Because e to the x times e to the x will be e to the 2x because we add the exponents. Okay, can I leave this as my answer? Why not? Okay, it is silly. We have a fraction of a fraction, which is a complex fraction. So this is creating the issue right here. Okay, we could factor on e to the x to try to simplify things a little bit. Good idea. We'll roll with that. We got 1 over x. Can't have negative exponents in our answer. Minus natural log of x all over e to the 2x. Okay, what do you notice? Yeah, you can cancel out one of the e to the x's, can't you? So we end up with 1 over x minus the natural log of x over e to the x. Still have my fraction issue. So I have to make one fraction. I have to find common denominators, so I'll multiply the top and bottom of this guy by x, and I get 1 minus x natural log of x over e to the x over 1. Multiply by the, get 1 minus x natural log of x over x e to the x, and that is my derivative. Beautiful. Go get some brain food, folks. Okay, f of x equals the square root of natural log of 2x minus 1. We need to take the derivative. What rule do we use? Chain rule. What is the inside function? Good. What is the outside function? Under the 1 half. Should the old half. I know what's the derivative of u to the 1 half. 2 is u. And how do we take the derivative of natural log of 2x minus 1? Okay, chain rule again. Side. X minus 1. Outside. Natural log of u. 2. So we multiply those together, we get 2 over 2x minus 1. Now again, you don't have to set up the chain rule the second time. Just to show you, in fact, as you do that, think through it on your own if you like. If we multiply these, the 2's will cancel, correct? We end up with 1 over the quantity 2x minus 1 times the square root of 2x minus 1. Oops, sorry. Square root of natural log. Really good, that's why I hate it. It's just like, sometimes I wonder, like, what if somebody's watching and we're doing like half this money? It's that happened the other day. All right. So this example here, we have 2 more. I had the other group do this one on their own. What happened with that? Think you're up for the challenge? Oh wow. 2 minutes. Go. 2 minutes left. Go. Set it up. That's the fighting attitude. Just wait for Mr. Dentist to do it. How about this? I tell you to set up the quotient. You know how to set it. Okay? Let's do sine of x over the square root of x. Come on. Good. That's the quotient rule. Go. 5 natural log of x is 5 over x. Start to set it up. You guys know how to do